Hi guys, today we're going to be doing factoring review. All these methods I'm teaching today you've learned back in Algebra 1. We're just going to quickly refresh them and do some examples. We're going to be learning 3 different methods today. We're going to be doing GCF, basic trinomials, and then difference of squares. So the first one we're going to be doing here is greatest common factor, which we shorthand to GCF. This is when you're looking at all your terms in your function, and you're seeing what they have in common. That can be a number like 2, 4, 5, whatever it is, and it can also be variables as well. So here's our first example, 15x squared minus 9x plus 3. When I'm looking at all of those, all right, they all have a factor of 3 in common. So I'm going to pull out or divide a factor of 3. So when I remove a factor of 3 from 15x squared, I would get 5x squared. So essentially we're just dividing by that 3. From 9x, I'm going to pull out a 3 divided by 3, and I get 3x. And then from 3, if I do 3 divided by 3, I get 1. And from here, that would be my final answer. I pulled out a GCF. Example number 2, we've got negative 2x to the fourth minus 5x cubed plus x squared. I don't think they have any coefficients that have a GCF, but they all have an x squared in common. So we're going to remove an x squared. And what ideally you want to do, this first term here, you ideally want it to be positive. So I'm also going to pull out that negative sign to make it positive. So I'm going to be removing a negative x squared from each term. If I remove a negative x squared from negative 2x to the fourth, I get positive 2x squared. You essentially subtract those exponents. If I pull out a negative x squared from that negative 5x cubed, I get positive 5x. And if I do x squared divided by negative x squared, I get negative 1. And that would be my final solution. All right, the second term second method we're gonna be learning today is trinomials. And this is kind of the more time consuming. I call it the guess and check method. As you do more and more problems, you get better at kind of guessing and not having to do as much checking. So the first example, it's gonna be an easier one where your a value is just 1. So our first example here is x squared minus 9x plus or minus 36. So the trinomial method is most common for you make your sets of parentheses. The first thing that goes into there is what times what gives you x squared. Well, x times x gives you x squared. The second numbers in here are going to be what times what gives you negative 36. So let's make a list of things that multiply to 36 real quick. I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9. All right, and 6 and 6. There's a lot of things that multiply to 36. Now here's how we kind of narrow that down. We're trying to figure out if I were to add or subtract those two numbers there, it would actually equal 9 somehow. So 1 and 36, I don't think there's any way I can make that equal 9. 2 and 18, I can either make that 20 or 16, and that won't work. 3 and 12, right? I can either make that into 15 or 9. Oh, that might be our answer there. Let's start with the other ones. 4 and 9, that can either go to 13 or 5. That won't work. 6 and 6, either 0 or 12. So it's definitely our 3 and 12. So now this is where you kind of do your guess and check. You're going to do the inside rainbow, 3 times x, which is 3x. And my outside ones, x times 12, which is 12x. Is there any way you can make those into negative 9x? I can make them if I have a negative 12 and a positive 3x. So my plus would go here and my minus sign would go there. So my answer is going to be x plus 3, x minus 12. And I have factored my trinomial. Let's try another one here. We've got 2x squared minus x minus 15. So I'm going to make my parentheses. First thing, what times what gives me 2x squared? Well, 2x times x would give me 2x squared. What times what gives me 15? Well, let's see. I have 5 and 3. So if I do 5 times x, I get 5x. 2x times 3x gives me 6x. Is there any way I can make that into negative x? Well, it could become negative x if I have a negative 6x plus a positive 5x. So it'd be plus 5 minus 3. So my final solution would be 2x plus 5, x minus 3. And not all the time are you going to get it right in the first time. Sometimes we have to kind of erase and keep trying. right, example 5 is a little bit more difficult. The reason behind example 5 being more difficult, that first term is 12x squared. You're going to have multiple things that multiply to 12x squared. So I'm looking at making my parentheses here. What times what gives me 12x squared? Well, I know 12x and 1x are going to give me 12x squared, but I kind of avoid those a lot. I know that 4x and 3x gives me x squared. And I know that 6x and 2x also gives me 12x squared. We're going to have to kind of guess and check a lot of these. The second number we're looking at is 5. What multiplies 5? Well, 1 and 5. I don't have a lot of options there. So let's see. I've got 1 and 5. Let's check over here. I've got 1 times 3x. That gives me 3x. 4x times 5 is going to give me 20x. So if I combine those, is there any way to make that into negative 4x? Not really, because if I make it negative 20x, that'd be negative 17. If I make it negative 3, right, that becomes positive 17. So I don't think that's our combination. We can try erasing it and moving those numbers if we want. So let's see, now I've got 15x and 4x. That can either make me into 19x or 11x somehow. That still isn't it. So I don't think 4 and 3x are our options. So let's try 6x and 2x. So I'm going to try 1 and 5. All right, I've got 1 times 2x, which is 2x. 6x times 5 is 30x. I don't think that's going to give us that negative 4. So let's try flip-flopping them. All right, now I've got 10x and 6x. Is there any way to make that into negative 4x? Yeah, I can make the 10x negative and the 6x positive. So it's going to be negative 5, positive 1. So my final solution here is going to be 6x minus 5 times 2x plus 1. Like I said, so that's an example of us trying a lot of different things and it might not work out there. All right, this one, we've got a lot going on from example 6. We got negative 27x squared minus 36x minus 12. We need to pause here. Always check for your other things like GCF. If you look at those numbers, negative 27, negative 36, negative 12, I think all of those have a negative 3 as a common factor. So I'm going to factor out that negative 3 first. When I do that, I get 9x squared plus 12x plus 4. All right, so remember, in your final answer, you need to continue to have that negative 3 on the outside there because it's still part of that original problem. So I'm going to make my parentheses like I normally do. What times what gives me 9x squared? Well, I've got 9x and x, and I've got 3x and 3x. I'm going to try the 3x and 3x first. What times what gives me 4? Let's just try 2 and 2. So I've got 2 times 3x, which is 6x. 2 times 3x, which is 6x. Is there any way I can make those 6x's into 12? And that answer is yes. I can make them both plus. All right, so my answer would be negative 3x plus 2 times 3x plus 2. And you'll notice here that our parentheses are actually the exact same 3 things. So 3x plus 2 plus 3x plus 2. So I could actually rewrite this as negative 3 times 3x plus 2 squared. And that would be my final solution. The final method here is difference of squares. Big key word here is that word difference. Difference means subtraction. So we have to see subtraction in here in order to do this method. And it also says of squares. We're looking for those perfect squares. Remember from our operations notes. Radical 4, radical 9, all those numbers like 4 and 9, 16, 25, all those are perfect squares. So we actually have a formula for this. It says a squared minus b squared. When you see perfect squares, it's actually going to be a plus b times a minus b is how that's going to factor out. So here are some examples. In example 7, we've got x squared minus 25. Well, x squared is a perfect squared because x times x gives you x squared. 25 is a perfect square because 5 times 5 gives you 25. So I would actually say this is x plus 5 times x minus 5. And that would be my final solution. Up next, we've got x squared plus 16. Well, x squared is a perfect square and 16 is a perfect square, but here's the issue. It's not subtraction. So this is actually not factorable. So we cannot do this one because it has to be subtraction. All right, we got negative 48 squared plus 3. Well, it's not subtraction, and 48 and 3 aren't perfect squares. But let's check for a GCF. I think 48 and 3 have a common GCF, common term there. I think they both have 3 in common. And I'm going to try to pull it out that negative as well. So I'm going to pull out a negative 3. I get 16x squared minus 1. Now let's look at those terms. Is 16 a perfect square? Yes. Is x squared a perfect square? Yes. We have subtraction, and is 1 a perfect square? Yes, so we can now break this up. What times what gives me 16x squared? Well, 4x times 4x would get you that. What times what gives me 1? 1 and 1. So that would be my final solution.